Okay guys, we are at Latour's Auto doing a 2012 GMC van with a left rear ABS fault. It already had a new sensor put in it and it continues to set this code. The code on the scan tool shows a C0045, which says left rear wheel speed sensor circuit fault, short to battery or open. And before we turn the camera on, I pulled up data, put the car in gear, started it, ran the wheels, and I'm getting a left rear wheel speed signal, so we might scrap this whole thing. Maybe it's fixed and the code never cleared. That's my concern. And I was like, Caleb, should we turn the camera on because we're gonna lose this code if it's a history one? And yeah, so that's what we did. We just turned the camera on. I'm gonna clear the code first. I'll show you the wheel speed signal on the scan tool. We'll clear the code, we'll go from there. So first thing we'll do, guys, is we're gonna clear this code. Display codes, current codes. Yeah, I can't get rid of that code. How strange. That's what Pete told me too. It said it was current. But if I go to the data display, no, we're not gonna see front wheel speed because our wheels are on the ground. So we'll probably get front wheel speed codes in this test, but I don't care. We're focused on the left rear and the right rear for this. And see, they're both moving. Now, we may not have the same speed for both if I rev it up a little bit, just because the wheels are off the ground and this is an open differential. Looks pretty even right there. But yeah, I mean, we got signals on both. I'm on the brakes, wheels are stopped, off the brakes. So let's exit this data. Codes menu, display. Yeah, man, it's so weird. Left rear wheel speed circuit, okay. Usually these won't clear with the engine running. I'm not even gonna try. We'll go key on. So, I can't clear the fault, but I have a good signal. So the question would be for me is that maybe substituting that left rear signal with the right rear on the scan tool. I've never seen that on an ABS system, but I have to consider that. And I hate to get in and start unplugging things, but I want to prove that concept by unplugging this left rear speed sensor and see if I have a signal. That's very odd that I have a signal and can't clear the code and it's saying it is a current fault. I'm gonna try one more time. I'm gonna try this again. I'm gonna cycle the key, wait 5 seconds, key on, clearing the codes, and hitting continue. I can't get rid of this code. And it is saying it's a current fault. Okay, so let's go back to our data. We'll look at our left rear and right rear. I'm just gonna unplug this connector, which I know will be a hard fault. And I just wanna see if I have a mile per hour reading that maybe the scan tool is substituting. Like I said, I haven't seen that before, but I have to consider it. How weird. So it's not a substitution because see if we get a different code now with that unplugged. I had no wheel speed signal. Oh, strange. Same fault. Or no, new faults, I should say. Oh, it's just so weird. That's like I just can't clear the code. I don't see a reason to jump in this and start doing like pinpoint testing on the harness if I'm getting a good signal, which I have. I didn't expect this. I feel like my scan tool is not clearing this code. I'm gonna try it again. Clear codes, yes. Continue. Display codes, current codes. Damn it. How weird is that? In the common replaced parts, there's a headlight bulb listed. What? For the left rear wheel speed sensor? Why is this code setting? Let's go back to our data again. There is no reason for me to do pinpoint testing on this. I have a code that won't clear. I have seen with GM's issues with the ABS system not clearing with the engine running. So you know, shut the car off. Yeah, I don't know, a battery disconnect and a cap discharge maybe? I don't trust the code. Let me see if there's something with this C0045 in the troubleshooter on clearing it. Okay. Receives ignition voltage from the EBCM, provides a square wave back to the module, right? So this is a digital type speed sensor. Same as my truck. We'll put a link here for my truck on my ABS sensor on my 09 Silverado. There's a sub code here. See, it says C0045OF, C004502, C004505. What was my sub number? Let me go back. Symptom 05. So I'm reading that right in the code description. Our 05 symptom is short to voltage or an open is detected in the signal circuit or low reference circuit. Except I have a good signal. Conditions for clearing. Conditions for setting the DTC is no longer present. EBCM clears history when a current DTC is not detected. Okay, nothing helping me there. Diagnostic aids. I'm just scanning this real quick. It might have maybe a improper voltage signal. We could compare left and right side maybe. Nothing special in here. Just trying to clear the codes from here. Cannot clear it. Okay, so I'm kind of like, I wasn't expecting this. I feel like I say that like every time we turn the camera on lately. I was not expecting that. I'm not expecting that. I want to do a voltage measurement, just static, between the two sensors and just compare them, see what I have. Okay, that's what I'm gonna do. Just going directly to my lab scope, single channel, and let's get some numbers in here for you guys. 20 volt works. Definitely gonna drop my time base, about 50 milliseconds. Ideally, I really wanna go directly to the battery for this because I'm gonna compare left and right sides, and we're in the Rust Belt of Pennsylvania, but I should be able to do it here on the frame. I don't have my power probe, which I usually use, or my ground lead because my son has my truck. He's going to Rosedale now and my tools are in my truck. So we'll go to this frame bolt right here and hopefully make a good ground out of that. We'll see with the two signals. I'm going to do this plugged in, back probing the harness side of the connector. We probably should measure the known good side first, but this was working, so I didn't notice, did that line steady out when I made contact? Yeah, looks like it. 0.02. Okay, basically nothing on that one. Yeah, that's low. That voltage is low. Okay, sweet. This should be a 12 volt from memory. This is showing me 4.6. And is this the one the square wave rides on? Let's see. On some of these digital sensors, they'll send a 12 volt feed and then they'll ride the square wave on the feed. And on others, it'll ride on the ground circuit. Okay, but I think that voltage is low, which is why it's flagging this. So that means we're gonna have probably corrosion in the wire. We're gonna have a break or a chip in the wire somewhere, and we have a voltage drop that's occurring. It's enough voltage for the computer to see the signal, but it's flagging the code because it's not the right level. That's what I think we're looking at. Make sure my ground is good first. Can't get it any higher than 4.6 volts, so I'm trusting that ground now. Switching back to my other wire. 0.01 and steady. Now what I want to do, change this to, I had no signal at 20 volts. As you see there, I'll show you again. I got nothing at 20. Let's change this to 1 volt. I should have a square wave when I turn this. Not on that wire. So this is going to be on the signal then. So 4.5 volts I'm showing. And if I turn that, you're not going to really see the square wave. It's too small. It's there. Let's go a little bit longer time base. I saw something there. We'll go 1 second because I'm spinning it by hand. So there's your kind of square wave there. Not very clear. To magnify that, what we want to do is select AC coupling and then drop this to 1 volt. And now it will just show changing voltage, and I should be able to see that square wave better. So it's not even a square wave, it's showing an AC sine wave. So this is different than my truck. Now I'm confused on this signal in general. That should be a square wave, not a sine wave. I know I picked AC coupling, but that just blocks the DC constant. You'll still see digital signals on off on an AC scale. Let's go to the other side. I'm speculating, and I don't need to be. We have a known good on the other side, and then I can talk a little bit better about what I'm seeing. All right, let's get off AC coupling for a second. Go back to a 20 volt. Gotta find a known good ground. This bolt right here on this bracket, we'll use that. And we'll start at the top wire, harness side. Get you a digital number here too. So 0 volts showing minus 0.05 on that wire. And then this one should be, it's completely different. This is showing me 0.76 of a volt. Is it my ground? No. That's with no ground. 0.76, completely different voltage readings. This should be, one of these should be a 12 volt. This is an AC sine wave. Let's change this to a 1 volt and AC couple it. Much bigger signal, right? This one's huge in comparison on the same scale, right? Frequency. So service info was wrong on this design. This is not a digital sensor. This is a standard AC signal. This 0.76 of a volt is going to be 5 volts if I unplug it. So let me change that to 20 and let's get that signal back. Where did it go? I was showing 0.76. What happened to that? That's now showing 0, but I'm gonna unplug it real quick. Should go to 5. It just flagged a fault. You hear it. It stayed at 0. Going back to the top wire. 0 volts there, unplugging it. What? So these will use a bias voltage when it's a standard variable reluctance sensor. That's what this is looking like. Not all of them will use a bias, so I can't totally rely on that. But when I first started, I saw 0.76 over here, and now I got 0. I gotta trust my tool, and I don't. Oh, this is still, I still have this set to AC coupling. That's my fault. Scratch all of that. This bottom one should be near 5 volts. It is. Okay. That's what I wanted to see. You got to be careful with what you're doing with a scope, man. I still had that set to AC coupling. So 4.7 volts is open circuit voltage on a bias type VRS input. This is not digital. This is a old school design. Plugging this back in, you're going to see this voltage drop. Right, to 0.7. There was that 0.7 of a volt that I wanted to see originally. The other side's 0. So it's dropping that bias so that it's really inside the computer. I have lessons on this too, by the way. This would be chapter 21 material on my website, ScannerDanner Premium, in the classes I teach at the school. This would be one where we have 5 volts as the source that goes through a resistor in the module before it comes out to here. And then the other side is dropping across the external resistor. So resistor in the computer, resistor is the sensor. And that's why we see that drop from 4.7 down to 0.78. Plugged in. Unplugged, what happens? Watch. Watch the voltage unplugged. Goes to 4.7 volts. Okay, near 5. Some of that voltage, my meter is going to be dropping it. Plugged in, goes back to 0.7. Sine wave, no need to AC couple this anymore. We can just leave it on a 20 volt for the rest of what we're doing. Actually, we'll do 10 volts just to make that a little bit bigger. And then watch as I turn it. All right, that's on a 10 volt scale. Maybe we'll drop it to 5 to emphasize how weak this signal is on the other side. We'll go 5 volts. Drop this line down. This line's gonna look different on the other side too, because our baseline is different. This one being 0.7, that one being 4 volts plugged in, okay? Watch your signal. Let's get a peak to peak. That hit about 2.3 volts on the max and 0.3 on the min, so roughly 2.5 volt swing on that sine wave, okay? Known good, we'll call this. Let's go to the other side. All right, so first thing is service info is wrong on this. This is an old school VRS design. Even though my 09 Silverado used a digital signal, an active ABS sensor, this van, even though it's newer, 3 years newer, is the older design. So got to be careful with service info for sure. Let's get our 2 signals. These are going to be plugged in. Remember, we had 0.7 and 0 on the other side. And notice on this one, we're reading 4.5. And that is my signal wire. And when I turn this, you see our sine wave. So the computer is actually still able to see that. But that bias line voltage is too high, which is why it's flagging this code. I know what the problem is, but let me just be clear. Let's make sure the ground is good. This is plugged in. This is going to be my ground circuit. This one should be 0, minus 0.005. If I take my ground clip off, you see the oscillations in there. Put my ground, did you see that, Caleb? Watch here. No ground on my scope. You see all that noise? Good ground on my scope. There is nothing wrong with this ground, which is important. When you have elevated bias voltage, we could have a bad ground. What this proves is it's not that. Going to the signal side, this one reading our 4.5 volts. The fact that this still reads a signal is crazy to me. What this tells us here, our wiring problem, we either have an open circuit to this sensor or the sensor itself. This is a new sensor. This is the wrong sensor. You think? Yes, 100%. Wrong sensor. Well, not 100%. Let's talk about what we're seeing. This 4.5 volts, so 4.3, watch when I unplug it. This will go to the 4.7 that the other side was. All right, there's your 4.7. What that tells you is your signal wire from engine computer, from the BCM on the frame or wherever it is, from the computer itself down to this sensor is good. That's the beauty of bias voltage. I have a ton of lessons on this. You guys got to make sure you check them out. It's on the website, ScannerDanner.com. I got a bunch here on YouTube too. But I have no reason, because I know how to use this bias voltage signal, I have no reason to chase this harness from here up. Imagine if you didn't know that and this has a new sensor in it. What are you going to do next? Well, let's change the computer. Guess what? You're not going to fix it. Well, let's put a new wire in it. Guess what? You're not going to fix it. Where is our problem? The problem is either a bad ground, which I proved it's not because we plugged it in, got 0 volts. Bad ground's going to have elevated voltage when you have a bias line. Really, just in general. Our problem is right here, Caleb. From here down is where our problem is. This is all new. Is it? Sub harness is not new. There's a connector here. Oh, I thought this sub harness was new. It's not. We're gonna focus on the sub harness now. I'm just gonna do some wiggle checks first, okay? If we have a connection issue, I'm gonna see this bias voltage drop. I'm really focused on that part of the circuit right now. Oh, and it just moved as soon as I touched this harness. Look at that. Look at that. That's awesome. Yeah, let's go. I'm gonna back probe this side now, and we're gonna tell you where this fault is. It's gonna be in the sub harness, which is awesome. Let's see what we get here on this guy. That's gonna be my ground, possibly. totally different number, 0.0 or 0.1. Make sure my ground is good. Yep. 0.1 on that wire. And yeah, 0.006, that's my ground wire. So my 0.1 here, I can't believe this was producing a signal. So crazy. Okay, that's my 4-volt number on the other side. So my problem is on that, watch, I'm gonna wiggle this harness, you're gonna see this number bounce. Not a ton, okay? But our problem is on the signal wire, not the ground wire. If my problem was on the ground wire, what we would see down here is that same 4.5 volts on both wires. And what we're seeing is 0.1 on the wire that read 4.5 up top, and we're seeing the same ground, 0.005, top and bottom, so it's not the ground circuit, it's the signal circuit. Coming back up top, Caleb. Wiring is fun. I freaking love this stuff, man. I still do, after all these years. I really do. All right, 4.3. Our issue is on this red wire right here. We're gonna find a problem. We have a huge voltage drop that's occurring in this harness between the red wire here and down here. I'm reading 0.1 down there, 4 volts up here. We can check this harness, this connector, by just moving the pin over to the other side. I'm afraid to do that because I might miss the opportunity. Let's stay on this side for a minute. See our 4.2 volts. Let's take this off of the frame. Okay. And now we're 4.7. Where's the brake? Where's the brake? It's gotta be right here. It's right there. Watch, I twisted it. Right there, watch. Yeah, let's go. All right, so where's it broken though? It still could be the connector here. Let's measure this side and see. You can hear it freaking out inside too. All right, so that voltage, reading 4.7 there, tells me my connector here is fine. It's not this connector, it's after this. We're gonna find it. We're gonna find green cruddies. It's just really cool that this had a signal. Oh, by the way, this shows you how weak, watch this. I'll just grab my pin. This shows you how weak this bias voltage is. So grabbing the pin and then touching the car, right?
Is that grounded?
Through my body, which is like 500,000 ohms of resistance. Just a weak signal, but bias voltage is freaking awesome to use for troubleshooting. So some arguments I hear about some of my material, but Danner, your case studies are getting really old and they're not relevant today. Incorrect. Nothing could be further from the truth. This is the same stuff we've been doing forever. Does not matter year, make, or model of the car. This is standard stuff, man. Okay, let's find our brake. Where is it? Right here. Right here. Ha! Right there. I'll pull it apart further. Ready? That signal's gonna change too. Right there.
Yeah.
All the strands are probably broken right there. I can't tell with my naked eye. I mean, they're definitely broken.
Yeah.
And the reason I know that is watch, when I put this together, watch the voltage now when I kind of touch them together. Do you see it drop? Because it's going down through the sensor. See it drop?
Yeah.
So that's me squeezing them together. Ha!
There you go.
That's freaking awesome. Is this ground wire got some damage too, but it's not open. So really both of those need to be repaired, which we can do. I mean, or change this sub harness, but we're here. Let's just fix it and be done with this car, huh? To be clear about this ground wire, because I said this ground wire has some damage too. It does have damage, but it's not damaged in a point where they're all completely open. That ground is still intact. There's still a couple of strands left on that ground. Mm-hmm. So we weren't having a voltage drop there yet, but we were going to. But it was the signal side. And this is not a active or digital speed sensor. It's just an analog one. Crazy that there was no rub marks at all from where that was. I mean, was it? No, like I should have focused a little bit more on that. You typically don't see that kind of rub through unless it's rubbing on something. So we've repaired ABS wires before, and this is an area where you got to be cautious about how you're repairing it because of vibrations, which is really what caused this in the first place. You're gonna see it like up right there, you go, just pulled it apart. And then the ground wire up, like I said, is not completely broken. I should be able to pull that one apart too, yeah. The wires are all black and corroded. This really needs this sub harness replaced. So I'm gonna tell, because look how nasty these wires are. I'm gonna tell Pete to get a sub harness for this, but for us, for this video, we're just gonna fix it. Like that's bad. This harness is just deteriorated.
The ground sides are completely black.
Yeah, this has been exposed for a long time. I might have to put an extension piece in here. Yeah, you can't solder wires when it's like this. I wasn't going to anyway. We like our heat shrink butt connectors. But when they turn black like that, like that's adding resistance. I know you can clean the surface of that a little bit. Yeah, this is gonna be a temporary fix just for us, just for this video. So you're gonna have movement in this axle. It's gonna bounce up and down. And yeah, kind of shorten this a little bit. The butt connector is gonna add a little length. Okay, I got a chance to show you guys something, which would be pretty cool. No ground, right? 4.7 volts, that's the signal wire. The ground would be through the sensor as the resistor, and then it drops on the other side. So what you're gonna see now is what a bad ground looks like. 4.7, I'm gonna see 0 on this side because that is connected to ground at the module. You see our 0.003. I'm gonna see 4.7 on this. There you go. 4.6, making some poor contact here, right? Let's go. Some of that too is my body. Remember, I can pull that bias down with me touching, but this would be what your bad ground would look like if I wasn't touching it with my finger. Let's see if I can make that stay. Good stuff here. Teaching as always. 4.62, 4.67. All right, that's what a bad ground would look like. So when I was measuring down there, if I were to measure this right now down at the bottom, we would see 4 and 4 with the bad ground. So this is just understanding, knowing circuit design, knowing how to use bias voltage. Fundamentals, man, as we always say, it always boils down to fundamentals. And then what I'll show you guys in this next step is when I'm putting this butt connector back on this circuit. I see 4.7 on the signal, but watch my shaky hand. Watch the lab scope whenever I get this connected. You're gonna see that line is gonna drop to that 0.7 that we saw on the other side. There you go. And squeeze. 0.8. And then watch your sine wave too. This is gonna be much larger. That's what we want. To compare before and after. I don't even need to measure that. I mean, we could get a mid-max because we did it on the other side. That's +4, -3. That's like a 7-volt swing. So I'm just spinning this side a little bit quicker than the other when I measured it. Now we'll be able to clear the code. Before I do that with the heat shrink and stuff and finish this, watch, we'll go scanner, current codes, no codes present, didn't even clear it. Current code's gone. History codes, yeah, I got right rear and left rear, right? So we'll go back. Current codes, watch this. We'll make a current code. There you go. That's why I couldn't clear it. It wasn't completely open. We still had a signal. The problem was that voltage level, computers using that bias line to determine opens and shorts. There's not even a signal here going on. This makes its own voltage on a VRS type sensor. chapter 21. And the computer doesn't need the wheels to turn to recognize a fault. It recognizes the fault without the wheels even turning on a sensor that makes its own voltage. How is it doing that? Bias voltage is how. Plugging it back in. Sorry for the noise. Watch the signal voltage or watch the code. Code's gonna go away as current. No code's present. We'll go back. We'll clear these out. History codes should now be gone. They are. Current codes are gone. They are. So Pete's not here. He went to get food. I don't have a lighter or butane, so I can't heat shrink these right now. This sub harness needs to be replaced. I really am not comfortable with this fix, given how nasty that harness looks. It's possible that this may go the way it is for now until he can get one. This is one of Pete's buddies. As soon as Pete comes back, I'll get that finished up. We'll heat shrink those and mount that. I'll have him order the sub harness for his friend. He'll probably drive it this way for a little bit. But great case study. I hope you guys followed that. I'm sure there's questions. We do a lot of stuff on this channel. We have over 700 videos on YouTube, and we have over 600 videos now on the website with a mixture of class and case studies. And we have a lot of training on this particular topic: bias voltage, variable reluctance sensors, digital sensors, the whole deal. So hope to see you guys on the website. That's ScannerDanner.com. If you have any questions, feel free to put them here. We'll do our best to answer. And then, yeah, we'll just see you next time. Pete was just asking me, where does he get the harness? And I said, I don't know, it's not my problem. That's Pete's problem on where to find it. I just don't like the condition of this sub harness. The wires are very deteriorated. I'm doing I'm gonna call this a temporary fix, okay? And he can drive it this way for a while, Pete, but I really think that he's gonna end up with problems with this.
Well, why don't I just get it then?
I'm suggesting that you do that.
Okay, I'm gonna do that right now.
Okay.
It's not gonna hurt to change it.
No, not at all. But just in case it's like back ordered or you can't find it, I'll leave this in a way that you can drive it. That is not a good fix. If Pete can't get this sub harness, I'm gonna have him use some of that Tessa tape and tape this up, because that's gonna end up like doing the same thing over time. This is what caused it, right? Just, I think maybe I might have been laying over here, but just up and down vibrations. If you can't get this sub harness, Pete, I want you to tape this up better right here.
Okay.
Okay? All right, cool.